What is a mire? A mire is a wetland in which the dead plant matter of the mire vegetation cannot be decomposed entirely by microorganisms due to the waterlogged site conditions. The plants consist of carbon, which is then sequestered into the mire deposits. We call this dead organic matter peat, and over time, the mire vegetation develops into peatland. Peatlands in the temperate climate region thus grow 0.5 to 1 millimeter in height per year. All over the world, peatlands have developed undisturbed over centuries to millennia and have removed large amounts of carbon from the global carbon cycle. What is the current state of peatlands worldwide? Globally, peatlands cover only 3% of the land surface, but they store twice as much carbon in their peat as all the forests on Earth, which cover 30% of the land surface. Worldwide, only 15% of peatlands have been drained, which is about 0.4% of the global land surface. However, this today causes 5% of all man-made greenhouse gas emissions. The majority of the world's drained peatlands are used for agriculture. Conventional agriculture drains peatlands and manages water levels by digging ditches and installing drainage infrastructure. Drained peatlands are usually used in agriculture for the production of hay or grazing of animals, often in intensive regimes with 2 to 3 cuts per year and high fertilizer application. Peatlands are also converted to arable land for further uses such as maize cultivation for animal feed production or biogas production. Drainage causes the water levels in the peatland to fall, and the once waterlogged peat is exposed to oxygen, allowing aerobic microorganisms to convert the organic substance stored in the peat. Thus, the sequestered carbon is released to the atmosphere as carbon dioxide. Under temperate climate, 1 hectare of heavily drained peatland, used as grassland, releases about 30 tons CO2 equivalent greenhouse gas emissions per year. Conventionally managed arable land on peatland releases about 40 tons of CO2 equivalent greenhouse gas emissions annually. On average, this corresponds to 150,000 kilometers driven in a medium-sized car. Literally speaking, that's almost 4 circumnavigations of the world. As a result, the peatland loses 1 to 2 centimeters of surface level per year, and it has to be drained deeper and deeper in order to continue conventional use. In the long run, conventional agriculture on peatlands destroys its own basis for production. The soil and the operating costs for maintaining drainage and counteracting the deterioration of soil properties increase continuously. This has already led to the abandonment of farming in many places. In the agricultural sector, peatlands occupy only a small fraction of the total production area. However, they produce disproportionately high amounts of greenhouse gas emissions. By focusing climate action on a relatively small area, significant climate change mitigation targets could be achieved in the agricultural sector that are in line with the Paris Agreement. How can peatlands contribute to climate protection? If peatlands are re-wetted properly, they remain permanently wet and there will be no more CO2 emissions. The average water level must be kept just below the surface throughout the whole course of the year, i.e. at 10 centimeters to 20 centimeters below the surface. The ideal water level is actually surface level. This helps to protect the climate by avoiding emissions. The ecosystem regenerates and new habitats and wetland biodiversity develop in the re-wetted landscape. In addition, water availability improves on landscape level as the water is held back in the restored peatland sites. Furthermore, the water quality in connected water bodies increases because the discharge of nutrients caused by peat decomposition is stopped and the plants growing in the peatlands filter the water as it flows through the site. Is agricultural production possible on re-wetted peatlands? The agricultural use of wet or re-wetted peat soils is called Paludiculture. The term is derived from the Latin palus, swamp, and culture, meaning the cultivation. In conventional agriculture on peatland, the site is adapted to the required production. Conventional agriculture drains and interferes with the soil, resulting in very high emissions. In contrast, Paludiculture adapts production schemes to the wet site conditions. Thus, significantly lower or even zero emissions are achieved. Paludiculture is an innovative wet agriculture on peatland that conserves soil and protects the climate. It follows three principles: farming on wet, including re-wetted peatland soils, working with site-adapted species, soil-conserving harvesting of above-ground biomass. Paludiculture is climate protection. It enables the production of renewable biomasses for climate-neutral products and value chains. These products can be used to replace conventional products based on fossil raw materials. So-called climate-negative products can even be produced if they confine the carbon permanently and replace products manufactured from fossil resources. Examples are durable fiber and construction materials. Paludiculture can also provide renewable biomasses for climate-friendly energy production, animal feed, food, medicine, and substrate raw materials for horticultural substrates. Peatlands must be wet, and agriculture can be wet.